Over the years, I met many people who rely on Excel type spreadsheet programs for their data analysis. They are mostly happy with the software, but occasionally they run into challenges that could be easily solved with R. To address this, I am creating a series of introductory videos on using R and Excel together. I do not expect you to switch entirely from Excel to R. If you are comfortable with Excel, you can continue using it for most of your tasks. However, for aspects of your analysis that are better handled in R, I encourage you to start integrating R into your workflow. You can perform the more complex steps in R, save the results in CSV format, and then return to Excel for rest of the analysis. This series is designed to help you ease into that process. This video will go over a few basic concepts on R. Keep in mind that this isn't an exhaustive overview of the language. I'll focus specifically on what you need to know to analyze Excel type spreadsheets. So what is R? It's an open source software environment used for statistical computing and data analysis. It was originally designed for statistical analysis and it's widely used in fields like biology, economics, social sciences. One of R's strengths is its powerful data visualization capabilities, allowing you to create clear and informative plots with ease. R also offers robust tools for machine learning. But for now, my goal is to introduce you to R in the context of working with Excel spreadsheet and similar datasets.
Here is how you install R. You go to Google and type install R. It will take you to a page with link for Mac OS or Windows, and you click on those links. For example, here is the Mac OS, and you will find a PKG file, and then you can download for your appropriate computer and install that. If you click on the Windows link, it will take you for the Windows installer, which is this one. You download it, double click, and once you finish the installation, you will find an R icon on your desktop or your Finder if you are using Mac, and then you can start using it. If you want to install R for Linux, then you need to type install R Linux. And for Ubuntu, which is the popular distribution, you can find the link for installation, and you have to type certain commands and then install. For example, you can run this command, or if you are installing in a server, then you can follow some of these links and you should be able to install. Once your installation is complete, you double click on the R icon and a window like this will open. This is called the R console, where you type commands and run R interactively. For example, you can type 12 plus 23, press enter, and R will give you the result. You will find the icon on your desktop if you are using Windows, or you go to Finder in Mac and you can type R and it will give you the R icon. And by clicking on the icon, you will get this window. So to finish and quit, if you are done, then you go to File and then do Exit. And when you do that, it will ask you save workspace image. If you say yes, then your work history will be saved. Next time you come to R, you will be able to access all your previous data and commands. If you say no, then nothing will be saved. Let me do cancel and show you something useful. When you type a command in R, for example, here I did 12 plus 23. If I want to go back to the command, all I have to do is just press the up button. So now I press the up button twice and I got this old command back. That's something useful. And then if you do Control L, you will clear your screen. So let me demonstrate how I can reuse the existing commands. So let's say I did 12 plus 23 plus 124 and I got the result. And then I realized that this number, the middle number, should be 24, not 23. So I press the up arrow, then go in, edit the number, and then press enter. And that's how easy it is to rerun your existing code. You press the up and down buttons and go through your previous commands. I was doing my taxes the other day and I had to add a bunch of small numbers. You likely come across such situations from time to time. In the past, I used a physical or an electronic calculator for these kinds of small calculations. These days, I prefer R because it has many advantages. Before I show them, let me show you how to use R as a calculator. You double click on the R icon on your desktop to open this R console and then type the expression you like to evaluate. For decimal numbers, you can use the dot and that becomes 12.34. So press enter and you get the result. Standard symbols for addition, subtraction, multiplication, and division apply. So here you do 12 plus 23 minus for subtraction 34. And then if you want to multiply two numbers, 2 star 3, that's multiplication. And then for division, you use this symbol. Okay. Here is why I prefer R over regular calculators. You can easily double check and correct your calculations. Suppose you realize that you typed a number wrong. You can press the up and down keys to go back to your previous calculation, and then you can edit your calculation. And then second advantage of R is that it allows you to evaluate complex expressions like this. Let me copy and paste some expression. So here I'm doing 0.9235 times this number plus this number and then subtract this number. So I get the result. And then I suddenly realize that I have error. So I can edit and redo it. But if you have to do this calculation in a calculator, you have to first add these numbers, save them somewhere, and then add these numbers, save them somewhere, and then multiply with these numbers. So in R, you can do this calculation in just one step. Also, what you can do is you store your result in a variable. Let's say you do x equals this, and you do x times 0.108. It will give you the result where it will multiply the original number by 0.108. And similarly, you can store this new result in y, and then you can do x minus y. Do all kinds of calculations like this. You can also use R as a scientific calculator. Here is the square root of 10. You type the function sqrt, which is square root, and then put the number. Or let's say you want to do e to the power 20. You do exp, which is the e to the power, and then put the number 20. If you want to do calculation with a trigonometric function, you type the function. For example, here is sine of pi over 3. Remember, the angle needs to be in radian because that's what R uses for these trigonometric functions. So you can do sine, cosine, and then tan in this way. If you want to get the value of E, you just do exp 1. Whereas if you type pi, that gives you the number pi, 3.141593. R has a number of other functions for doing all kinds of scientific calculations. I'm not showing them here. They are in the tutorial and you can look them up. And apart from the ones mentioned in the tutorial, R has very nice documentation where you can check these other functions. One powerful concept I'll briefly touch on here is R's use of vectors. A vector is a collection of numbers. every R variable can be a vector instead of a single number. For example, if you do x equals 1 to 100, this means x is a vector with numbers 1, 2, 3, 4, 5, 6 all the way to 100. And if you want to do square root of 1 to 100, you do square root of x, and in one step you get the square root of all integers from 1 to 100. So this is a real advantage of R, where you can do calculations using vector. I'll not talk about vectors anymore in this tutorial. I'll come back and cover this topic in a later tutorial. Let's talk about packages. If you use your smartphone, you know that you can install apps. So your phone comes with some core capabilities, but you can enhance its power by installing apps. R works in the same way, and the apps for R are called packages. Here I'll show you how to install packages and present an immensely versatile package named Tidyverse. Tidyverse is a versatile package that I compare with a Swiss Army knife. It's actually a collection of packages. Let me show you how to install it, and then I'll demonstrate one of its applications. So here is what you do to install a package. You type install.packages and then put the name of the package in parentheses and within quote. Install.packages Tidyverse. This installation will open another window, and you can just pick the default location and then click OK. I already have Tidyverse installed. I'm not choosing to install Tidyverse, but if you click OK, R will install the Tidyverse package. It will take a few minutes, and then you should be able to get Tidyverse in your computer. Let me do cancel and show you how to use the package. If you want to use this package, once you have it installed, you type library and then name of the package. It loads up the package, and then you will have access to a number of functions. I'll show you one of those in a minute, but let me talk about these install packages and the library step. When you quit your R session, you type Q, or you can do file and exit. If you quit your R session and come back, to use a package you need to run this line. You don't need to do install packages, it's already installed in your machine, but you have to run this again. I'm going to show you one application of Tidyverse, which is the %> operator. And here is what you do. Let me do a calculation without using the operator, and then we'll do it using the operator. So first step always is to do library Tidyverse if you haven't done it in this R session. So you type library Tidyverse. I already installed and loaded Tidyverse, so that's why it did not give me any prompt, because it's already loaded. So one calculation that you can do is square root of 100. If you do that, you get 10. With Tidyverse, you write this same function in a different way. So what you write is 100 %% sqrt, and you get 10 again. So internally, if you write a function like this, internally R converts that to this function and then gives you the result. The real advantage of using %% is this. Let's say you want to do log 10 of square root of 100. So square root of 100 is 10, and log of 10 of that is 1, and you got the result. The problem with writing these functions is that you have to keep track of a number of parentheses, and sometimes when you have big expressions, these parentheses do not match, you get error, and that's really frustrating. So the Tidyverse way of doing the same thing is 100 sqrt and then %> log 10. The way it works is you take 100, do square root and then get the result and do log 10 out of it. It's the same as this, except that when you write in this way, it feels more natural, and you run it and you get this result 1. So this is the advantage of this %% operator. It just makes your code look clean, and it's really useful when we have a number of large functions, and I'll talk about that in a later video. We are going to talk about data frame. You already stored the data that I gave you in the desktop. Now I'm going to use R to read that file. So the first thing you do is go to File and then do Change Directory. In my case, the file is stored in my desktop, so I click Desktop and then do Select Folder. And then the command that I type is df equals read_csv and then data.csv. And then R loads the file and stores in a variable called df. If you type df, you see this result. Here it shows the same file, and it's shown in a spreadsheet format. You have 3 columns. The first column is name, second column is weight, and the third column is age. And you see the same data that you saved in the file data.csv. You also have option of loading TSV file, which is a tab delimited file, or an Excel spreadsheet. Now the variable that you see here is called a data frame. A data frame is essentially a spreadsheet, and R has a number of functions to process a data frame. I'll be talking about that in the later videos.